Welcome back to the SSAS and MDX training sessions. So we are on the second session on MDX trainings. In last session, we discussed about the basics and we understood what is a set and what is a tuple, how to differentiate, what is a level, what is a member, what is a hierarchy, and what is a dimension, and so on. And how can you use multiple members from the same attribute hierarchy to define a set and different attribute hierarchies to define a tuple, and how can we have a set in between the tuple. So we discussed all the basic things, and not now, going forward, we're going to discuss about lots of functions. So MDX is nothing but the basic and the right syntax with some functions. Now you know how to write the basic MDX query. Now let's see how to use functions. You already started using few keywords and functions like members and non-empty, and we will be seeing more and more um, functions in today's session. So let's start. Before going with the new set of functions, let's see how to have a cross join. We already discussed about the cross join, right? Let's see how we can have a cross join in a different way. So this is a set, okay, and set can be used in a tuple, right, which will be your cross join. So if I have invoice date to calendar year, and let me reconnect this guy. I just processed it. So let me go to invoice date and let me get, for example, here is the year. Let me get the month name. So I drag month name here. From here to here, this is one hierarchy. And from here to here, this is a different hierarchy, which is created using the help of set. Now, this will do the cross join, right? If I execute it, it gives you 2014 every month of it, 2015 every month of it, breakup for the tax rate, and city on the column, city-wise breakup on the columns. Now, this is one way of representing the cross join. The other way is using the function. So whether you give, if you give this or no, it's not gonna make difference. So this is gonna do the cross join of the set of members from the calendar year hierarchy and the members from the calendar month. So this is about the cross join. Now let's see more and more functions. The first one, the one which we are very well aware of, members. How can you get the members of a hierarchy? Let me copy the same query, and instead of this, let me have a simple, what you call the tax amount or the profit in the columns. I just want to keep the query simple, and I don't need the weight class at this point of time, and I don't need such a big cross join too. So instead, what I'm going to do here is I'm going to drag users. So when I drag users, what it is going to return? It's going to return the only attribute. If it has only one attribute, then it will return that. Now, you all know what will happen if you have more than one attribute in the users dimension. Now, what will happen if I do members at the hierarchy level? We never tried this, right? So if I execute members at the hierarchy level, then it will try to get all the members of the only attribute that is available in the dimension. You see that? And if you have multiple dimensions, obviously it's going to fail. For example, instead of users, if you give city dimension dot members, then it's going to fail because it has more than one attribute hierarchy defined. So below gonna fail, right? So now this is what will happen when you use the members function at the dimension level, and if it has only one attribute hierarchy defined. Now let's see what happens when you give the members at hierarchy level. So city has a hierarchy, attribute hierarchy called city, right? So when you do city.city, it will try to give you all the members under it, including the all and all the members under it. This is what we have seen yesterday. If you go to this and if you go for members, it gives you all that is available in the members folder here, And if you expand this, it has all at the top, and then it has all the members of it. So it gives the data by the same. What will happen if I give members at a level instead of a hierarchy? What if I give the dot members at level? So it is going to give every member of it, and all is not part of it, so it won't return all, but it will give you all the members. And now what will happen if I give, or if I use the function members at the member level instead of attribute hierarchy level? I'm going to use a member now. So I copy the same query. Instead of city dot city dot city, I'm going to pick one city from here. So if I go, the one that I know which has data is Abbotsburg. If I give you Abbotsburg dot members, what it is going to return? Is it going to return any data, or it's going to return error? So it's going to return error because the members function expects a level expression for the first argument. It should be at least a level. So, but here I'm giving a member. So the members will not have dot members. That's the least level for the members function. But a members will have a children function. I mean, it may have children. Let me show you how it's gonna. So if I go here, instead of these members, if I execute children, I'm always confused with the spelling children. So when I give dot children, it will go on try to get the children of it. And there is no children for this Abbotsburg, which means if I click on plus, there is nothing to show here, right? There is no plus sign also. There is no children for that. That is why it won't return anything when you go for children at member level. But if you go for a different level of it, which has children, can you guys guess which member of this particular city has children? Can you guess the name of the member? There is no member that is coming from the source data that has children, but I can see the all member has children. So the all, if I go for all, and if I execute it, it's looking for this. Let me true, and it gives you all the children of it. Okay, if you see here, children function returns the members of returns the children of the member. As the name says, it gives you the children of the member, but the input for the children function is member. Remember that is very important. You have to give the proper input. If you know the input, if I say that the input is a member, it should immediately flash in your mind, oh, a member. Then it should be something like city.city.Abbotsburg, or city.city.all, or something like employee id.abcdef. It should not be like a level or a hierarchy or a dimension. It should be a member which can be given or which can be used with the children function. So if this is the only use, if children can get me only the children of the all, then why I need this children function? It's not that helpful to me. The reason is I can get the same data by executing. Let's say this gives me the same data. The members at the level will give me the same data. And also, yeah, this one will give me the same data. In that case, why I need a children function? Children function is not of much helpful, right? But children function with user-defined hierarchies or hierarchies. When I say hierarchies, it's not about attribute hierarchies, because attribute hierarchies has only two levels. The first level is all, and the second level is members of it. When you go by the user-defined hierarchies, then the children function will have a lot of benefits. Let's see one example of using the children function with a user-defined hierarchy. Do you remember any dimension that has user-defined hierarchies? I remember we do have date, which we created a user-defined hierarchy recently. I mean, yesterday only. So let me go to the invoice date. And instead of this, I'm going to the calendar year. Remember, I'm going to the calendar year of, let's say, 2014. And this is a member, right? This is a member of a calendar year hierarchy. Now, This member, I'm asking for children. Let's see what it's going to return. When I execute it, it gives me the children for the year 2014. What is the children? Children means the next level of it. The next level is month. Month has April. I mean, this is not sorted in order, but it should have 12 records, and each record represents each month of the year 2014. So this is the advantage. If you give any member from the hierarchy, then it shows the power of the children. The children will give all the children of that particular member. Instead of giving 2015, 16, every month's data, it gives you only the member that you have specified. It is like asking by showing a person who are the children of this particular person. You can't show everyone in the world, right? You will show only the children of that particular guy. So the same way, if you ask 2014 children, it's gonna give you 2014 children. And if I go one step ahead, and if I get all member of it, and if I go for a children, then what it's going to return? It's going to return me the first level after that all, whatever the children that it's going to return. So in short, if you take this is your all member, this has 4 years, and this has 12 months. Assume these are 12 lines. I'll write some a number of lines, and this has 12 months data, and this has 12 months data, and this has only 3 months data, let's assume. Now if I give all and dot children, then this gives me the value of this, value of this, value of this, and value of this. And if I select this member and ask for the children, it gives me the value of all its direct children, that is 12 months in our current case. And if I give this member, this may give me like 3 or 4 records, because that's the data we have in the database. Now let's go back and try to give a particular year which does not have all the information, maybe 2016. I'm gonna give 2016 data and asking for its children. If I execute it, this is gonna give me the months. It has everything except December, it seems, or November and December. It has 10 months of data. Yep, it has 10 months of data starting from Jan to October. So this is the advantage of children function. Now let's go to a different case. If I show a person and ask for a children, you can give the children of this person, right? Now if I go to if I show you a person, if I ask for the grandchildren, what will be the function here? I have to go for dot children, which should give me, theoretically that should give me the grandchildren. So in this case, if I copy the same query, and instead of 2014, if I go for all member and dot children, you all know this is going to give me the children of it, the next level of it, which is years. Now what will return if I run dot children. So the first member dot children is 13, 14, 15, 16, and I am asking for one more level down. How can I do that? Dot children. So what it's going to return? Is it going to return months or date or year or all? What it's going to return? If I execute it, it throws error, because the children function expects a member. It expects only one member as input. It won't work for grandchildren. This is not the function you can use for grandchildren. So I'll mark it as fail, because the grandchildren you cannot get using the children.children function. When you go for this part, this will give you 4 members, and 4 members dot children it won't accept. It accepts only single member. Okay, that is why dot children is not acceptable. It won't work in the MDX. You can go to only one level down using the children function. Now let's see a better function. I always get confused with this spelling. Descendants. So descendants is gonna solve the problem of getting the grandchildren information. But descendants function is little different compared to the how you have the children.children. Children.children is pretty easy. After the member, you just give the children.children. Now let's see the descendants. So I'm gonna give all as my input, and I'm gonna retrieve my months as my descendants, which means all member grandchildren. All is the first, here is the children, and this is the grandchildren, and this is the great grandchildren. Now let's see how to use the function descendants. Descendants of, there is IntelliSense not working. Okay, so what you need to do is the first member should be member. What member descendants you are looking for? So let's say I'm looking for all, and what level you are looking for. If you go for the descendants function, let me quickly show you how it's given and how to understand the functions. There will be hundreds of functions in MDX, and we will be covering now few of those. And if you need to know how to understand the functions. So for example, descendants function in MDX. This is how I'll go for any new function if I have to look or understand. Now I'm going for descendants, and if you see, this is the descendants function. The minimum thing is a member. Whatever is in square brackets is optional. You can give or you cannot give. And the second one is level expression. So in short, the descendants will take at least a single member, which should be a member expression. Member expression means it should be a member, like all in our case, or whatever 2016 of calendar year in our case. These are the members. And the second one is level expression. So you know what is level. So this is a level, calendar, month, whatever, this is the level. So this is why I explained the difference between level, member, hierarchy, and so on. Whenever you take any function, it will talk about what is the input. Is it a member expression, or level expression, or hierarchy, or something like that. Okay. So the minimum thing is just to give only the member expression. So let's see what it's gonna return if I give only the member. So it is gonna return everything, all the members. I'm not asked for it, but it's giving me all the descendants of it. So all, under that there is a year 2013, under that there is a month to April, under that there are 30 days. So it's gonna return everything, the descendants, the whole what you call the tree. It's gonna return every tree in the same order. That's the beauty of it. If you see year, and year has few months, and each month will have dates, and everything will be given. This is the basic descendant function. So you can control this output by specifying the level in the second member. Second parameter of this function descendants. So this function descendants accepts one or more parameters, and if it is only one, then it should be member, and if it is more than one, it should be level. So let's say I want to see only this level for the all. So give me give me grandchildren of all the hierarchy, all member of the hierarchy. If I execute it, it should give me all the months information. You see that it's giving me all the months information. So I specified month level. Whatever you specify in the second one, it gives you that particular level. Now, instead of month, you can also specify the second level, which is equivalent to the children, right? If I give calendar year, this is gonna give me calendar year, and this is children. And you can also go for the great grandchildren by specifying the level in the parameters. Like date is the last level. Here it skips everything. Oops, sorry. And it's gonna give you only the dates. It won't show you year, and it won't show you month. You can decide. You can tell the server what you want exactly. If you want all the children. So this is very beautiful when you specify. For example, instead of all, if you specify, let's say, for example, 2016 as the first parameter, which is a member, this means giving all the dates that belongs to the year 2016. And if I execute it, it gives me only 2016 data. So you will be having something around 275 days, because we have only 10 months of data, and it gives you every month data like this. So whatever you can't achieve using the children function, that is going to the grandchildren or great grandchildren, you can easily achieve using the descendants function. So now all these descendants function are pretty nice. There is another way of representing the descendants function. So I copied all the set other way for lazy people like me. So I copied all those functions and I'm asking the server to give me all member grandchildren, right? So what is the level of it? What is the number of it? Instead of giving the whole level, or if you don't know the level of it, level name completely, like whether it's a calendar month or calendar month name, what you can do is, if you know the hierarchy, all is the 0th level, which means the current level. This is the first level, and this is the second level, and this is the third level of the hierarchy, right? So month will be my second. If I give 2 instead of the whole level, it works the same way, but something is wrong here. Let me find out what is that. Non-empty is incorrect. I think I have not executed something. Maybe yes was missing before. I have not selected yes while executing it. Now if you see, it's giving you the second level of it. Similarly, what will be the year? It will be first level of all, or of, I mean first level from the member that you have specified. So it will be giving years, and similarly date will be the third, so I can give 3. Let me execute it, and it's going to give you day level. And what you have done here, so let me give 0. I specified 2016 and I specified 0, and it's going to return that current level, whatever the member belongs to. So member belongs to the calendar year, and it's going to give you the current level. And if I give, instead of 0, if I give 1 of it, then it's gonna go to the month level. So this is how. What will happen if I go for -1? Will it go up? No, it's not gonna go up. So it's gonna return nothing because it's not gonna go up. So this is one way of representing the level of the descendants function, the second parameter of the descendants function. So if you see, if you provide just all, it is giving the whole hierarchy. Or if you give all member or any particular member in the first parameter, and the second parameter, if you specify the level, it is giving you only the members that belongs to the particular level. Now, how can you control more than this in the descendants? Yes, there is some option. There is an option to control more than this. So for example, if I give 0, it gives me the current data, right? Whatever the current member. So you have a parameter, third parameter, with some keywords. Let's say self. What is the meaning of self? Self means give me the self level, whatever the level that you're talking about, 0 to self level. Then you may be wondering what the hell use of using 0 as well as self. There is no much, to be honest, but you can have a different keyword which gives you self and after. You are controlling the server to give only that particular level and the next levels of that. Right? It is giving you all the self and the next level. Now, you can also give only after. If you give after, it won't give you self, it will give you all the children of it. This is better, right? So to get only all the children of the next level, this after keyword is very helpful. Similarly, there is something called before. So this gives you before level. But unfortunately, there is nothing. Or what could be the reason? Let me give 1 and let me try before, and it's going to give you. So what it is going to happen is, when I give 2016, 1, it will try to get all the children, and then it is asking you, I'm asking to give only before thing, not the level that I have specified here. So then that is why it is going to give only 2016, the same, which is equal to 0 with self. And same way, you have one more keyword. Let me show you the data without the keyword before. If I execute it, this gives me month level data, and I can go for self and before. Okay, so this gives me what is the self. Self means the level that I have specified here. And before level, what is the before level? The before level is year. So it is gonna give me year as well as months information. So these are the few keywords. So there are, I mean, it's not mandatory that you have to use all the keywords in your every MDX query, but based on the requirements, you can use these keywords to return the result set in your reports. So this is about the descendants function. So let's see the other way now. We have seen by giving a member, you are going down. You are going down and using the keyword self, and before you are going up and down, or you are standing there in the same level and returning the data. Now, how can I go up? We have a function called parent. So this gives you like what is the what you call parent function. If you give any member, again this function takes a member, and if you give any, if you specify any member, let's say I blindly drag some member, right? So let me use the same MDX or same query, and instead of this descendants and all, I'm gonna drag a member from here, and if I execute it, this is gonna give me that particular member value. And if I select dot parent, so I'm taking every query, I mean new query every time, because I just want to give these queries to you for your reference. So if I specify dot parent, this is gonna give me the parent of it. I don't know what level is above, what level is one level up, but it gives me the parent. Who is the parent of this guy? So this particular date that I have specified is belonging to April of the year 2013, and you can see the same 2013 April month. Now, how can I go for his grandparent? Can I use dot parent? Is it gonna return any result to me? Let's give it a try. So parent dot parent works very well. The reason is parent gonna return only one member. That is why dot parent will go for the member, I mean the parent of that particular member. So if this guy definitely gonna return only one member. If it's gonna return multiple members, then dot parent may not work, because dot parent function requires a member, not a set, right? Now dot parent will give you grandparent information. Can I get the great grandparent if there is any? For that you need to go for dot parent. If I execute it, if there is anything, the all is the parent. So it return the parent. All as the output when you go for parent. What will happen if I go for one more parent? It says that there is no parent for this guy, so it's empty. So this is the beauty of parent. You can go to any level up, but the problem here is, if you have 20 levels in your hierarchy, you have to go for dot parent, and so on. And the another thing is, you don't know which level you are going to. You just know the level name, but you don't know the level. So there is a function called ancestors, which is similar to the descendants, but in opposite way. So let's quickly see the ancestors function. So the ancestor function, I can easily copy, let's say, okay, I don't want to copy. Let me use the same query. And it works similar, very much. The syntax is very close to the descendants. Very, very close. Only the keyword changes. So let me go for ancestors. And of this guy. And let me execute it. And too few arguments were passed to the ancestors function. The minimum argument count for that function is 2. So the major difference between descendants and the ancestors is ancestors expects a level. It won't go for all the levels, just like how descendants function has done for us. When I give only all member, what happened? It has given all the children of it, right? So the same way the ancestors will not work. Ancestors expects a what you call a second parameter, which is a level. So what level up you want to go? Let's say I want to go to the year of this guy. So in that case, I have to drag and drop the year in the second parameter. And if I execute it, this guy gonna give me the year that this particular member belongs to, and the whole sales of it will be given. So where you are going to use this, you can use this in calculating the percentages. Percentages will be generally like current member divided by parent member, right? If 2016 has sales of 10 millions, and January of 2016 has sales of $100, then what is the percentage when you calculate? It will be 2016 January divided by 2016 January dot parent value, that is $100 divided by $10 million or whatever the number that I have given. So in those cases, this parent or this ancestors function will be very helpful, but you need to specify what is the level that you are going up. The same way, you can go, or you can say by the key, by the number. If I execute it, it will try to go up by 3 levels, and it is all. And if you give 1, it will just go by 1 level. And if you give 0, it will stay in the same level, and it will return the result set. So now it is going up to the month. So how about self and before? Will that work? So if I execute self, it's going to return too many arguments. So it accepts only 2 arguments. The self, the keywords will not work for ancestors. Ancestors is pretty simple version of the descendants, but it goes in the reverse order. It is mandated to take 2 parameters. One is the member, and the second one is level where you want to go up. Then in that case, how can I go to the all the hierarchy? How can I get all the hierarchy just like how I got for the all member when I give an all member in the descendants? For example, let me execute it here. I think I have it somewhere here. If I execute it, the first query, if you see, it is giving me all the children of all levels of all members, right? So how can I get a similar one? If I give a parent, how can I go and navigate it up? I have a function called ascendants. Definitely the spelling is wrong. Ascendant or ASENDN, ascendants. Okay. So ascendants function, this goes in the reverse order to the the descendants. So I'm using the ascendants function instead of this, and I'm giving only one member, and it won't take anything. It just takes the member. Or if I try to give 1, it goes like this up to too many arguments were passed. It takes the maximum argument count for the function is just 1. So that too you have to specify a member. And if I execute this ascendants, what it's gonna do is it's gonna give its history. So this is the member we have given, and its parent, and its parent, and its parent. So all member sales is this. In that 2013 sales is this. In that April 2013 sales is this. In that this particular day sales is this. So this is how you can go for ascendants. I've never tried by giving the whole level in this one. Let's try that. If I give level, will it accept? Theoretically, it should fail. The reason is it accepts only member. So that is why when I give dates, it's gonna fail. If you want this kind of data, whatever you are expecting to get out of this query, you can use descendants function, which is similar, right? You are giving a whole level and asking to give the parents of every member of it. So this is ruled out. Now this function, it gives you year, whatever, it's parent, and there is a function called hierarchies. If I remember the spelling, wow. So this hierarchies function, what it will do is it will show in the proper hierarchy. Like for example, this is showing in the reverse order, right? The actual hierarchy is, it should be in ascending. So I can put the result of this ascendants in between the hierarchies function, so that it will hierarchize the data for me. You see, it just returns the data. It returns the data in the proper hierarchy. So this is the only use case that you can use this hierarchies. Or maybe there are a few other use cases, but this is the only one that I can give as a good example for you guys. So these are the functions of like parent, ascendants, ancestors, and hierarchies. Here I have given a set for the first parameter, right? So I've seen the function here, the function expression, the function syntax, and it expects either a member expression for the first one or the set expression and the set expression for the same. Or this distance means it's a number that we have tried 0, 1, 2, 3. This level expression is nothing but the level that we have given. This disk flag is nothing but the description flag which we have used self before and after, right? So now it is saying that you can also use set expression. So I've tried the set expression by giving 2015 and 2016 in the Descendants. So it works. So that is what I'm trying to explain you. Whatever you look for, let's say for example, Ascendants or Ancestor. If I go for Ancestor, you should be able to understand the function by reading this syntax. If you say Ancestor is accepting member expression, comma level expression, member expression, comma distance, which means 0, 1, 2, 3. It has only two combinations, possible combinations. Now, if I try to give the set for this, then it's gonna fail because the syntax doesn't accept what? A set in the first parameter. So let me execute it. I change it to the ancestors and I've given a set in the top in the first parameter and the integer value distance in the second parameter. And it says that ancestors function expects a member expression for the first argument. So keep in mind, either you should be able to understand the function by going through the syntax or at least by seeing the error message. If the error message says that the ancestor function expects a member expression for the first parameter, this is my first parameter, and I'm giving a set, this is gonna fail, right? So this is how you should analyze your parameters of your function. Now we have seen about going up and going down, like parent and children, right? Now how can you get the brothers and sisters? So we discussed about parent, we discussed about the children of a member. How can I get the brother of it? So for that, let me show you something real quick. This is all. It has 4 years and each year has some months, right? So let's take this guy. This guy dot parent is this guy. And this guy dot children is set of these guys. So then what about the brothers? The brothers are the guys here. Right? So this gives you the brothers information. The brothers means the level, same level values information. So how can we get the brothers information? We will quickly see that now. So there are multiple ways of getting the brothers information but there is no function called brothers. That is why the brothers info. How can we get that? So let me quickly go to the year and let me use the same function. Sorry, the same query. And let me take out the ancestor and all. This is a discussed case and nothing. So this gives me 2016 information, and you know the parent will give me month, all member, and the children will give me months. How can I get all the remaining years? Who are my brothers and sisters? Who are the brothers and sisters of 2016? So you can do that by going to its parent. This will give you the parent information, all dot children. So parent will be single member. So children can be used along with the parent. So this gives you the brothers and sisters of this guy, right? So this is how you can get all the remaining members. Let's say you got some input, a dynamic input. It can be month, it can be year, it can be something, but you have to get all the members of it. How can you get that? Dot parent dot children will give you all the siblings, all the brothers of it. And now, how can you get the first children of this? You want to get the elder brother, the big one. So how can you do that? So you can use the same dot parent function, but in return, after that, first child function is there, which gives you the first children of the particular brothers and sisters. If I apply the same, let's say for example, for a month, calendar month, this is a very useful one when you have to get the first month sales, last month sales, or something like that. if I give June of a particular year, the year is 2014, in theoretically it should give me January data, but here it will give me April data of 2014 because I have sorted it in the alphabetical order. So the first child will give you whatever the first member that it returns when you expand that 2014, right? Now when I say that all under 2014, I've given this particular month. What month I've given? June, right? So what is the first brother of it? April, and the last brother is September. Now if I go for the last child instead of first child, oops, it should give me the September information, which is the last brother of all the brothers of this particular parent. I mean, all the children of this particular parent. So this is how you can get the first sales or the last sales or of a particular level or all the brothers by using dot parent dot children. Now there are other functions too to get the siblings information. Let's say, for example, instead of parent dot child, we have siblings. So this, what it will do internally is it will go to the parent and it will come back to the children. So it is going to do the siblings instead of that parent dot child or parent dot children. Children, you can use siblings function to get the siblings, which means the brothers and sisters of that particular level of the member that you have specified in the parameter. Or you have given as an input. Now let me use the same query. Can I get the first sibling? If I execute first sibling, this is gonna give me the first child, first brother, and similarly the last sibling will give me the last brother. So these functions, if you see, the only thing that you need to understand is how to interpret the parameters and how to understand and how to use the parameters. So if I said if the syntax says that last sibling takes a member and it returns all the last brother of the hierarchical level, then you should be able to understand what it is. So that is why it's very important to practice the core concepts of the MDX as well as analysis services levels and hierarchies and user defined hierarchies, attribute hierarchies, and measures. So this is about the siblings. This is how you can get brothers and sisters information. So this doesn't look good, right? So let's sort this issue. This is not in ascending order, and this is always, people expect to show to see December as the output for the last sibling, but it's showing something else. So for that, let me go and correct it in the analysis services real quick. So the analysis services, I have not given the sorting properly, and let me go to the dimension date where I have this hierarchy defined, and I think for calendar month label, this is causing problem because I've selected the month. Instead of month, I can select the number, which will be 1, 2, 3, 4, 5, 6, and so on. Calendar month number, and let me take it out and have the name as the label, so that the label will be shown to us and the number will be used for sorting. And if you see the sort of this particular attribute, it should be by key, order by key. So this should work unless it throws some error. Let me quickly process this dimension to see if it is working fine or if it requires any fixes. Okay, as expected. The reason is it is saying there is a duplicate data key because the month is given as 1, 1, 1. You see, what you call 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and the same numbers will be repeated in every year. So to provide uniqueness, I'm gonna add year as well to the key column. Thus you can provide the uniqueness. Now let me deploy it and let me process it real quick so that it should be in ascending order. The months will be in the ascending order. The most common thing that users complain if the data is not in ascending order, and even you feel it's awkward if you have the data in the ascending order by the month name instead of month number. And I think few queries will not work here. I'll show you what those queries are by executing it, and also I'll explain you the reason. Okay. So now let me close it and let me execute this query, which was working well before, and now it is not returning any data. The reason is I'm using a key. Ampersand means I'm trying to refer the key of 2014. Now the month key has been changed. The month key has been changed to the year dot month combination, right? So what I mean is, let's say if I reselect something from the month here, you can see how it will be. You see it's ampersand 2014 ampersand 11. This is how the representation, because the key column has been changed to the year and month composite key. Two columns in the key column. So this is how you should be representing if you want to go by key column. The simple fix for this query is, so wherever you have something like this, just replace the ampersand. Then it will be the name column, and that is the name column we have. And I hope, okay, only 5 occurrences. I doubt that. And this should work. The name column is what we are referring now, and it is gonna return. So the June first child is John. It is in ascending order now. And similarly, if you go for .parent.children, it should give me all the children. Where is the month? There is no month. Okay, all the children's in ascending order. Let me select this, and you can see it is giving me Jan, Feb, month, March, and so on. So this is a quick fix, and it's all good, right? So let's see some other functions. I would like to take cousin function here, which is little trickier, but let's give it a try for that. Cousin function. So the cousin function is kind of brother function. It gives you the brother, but at the level of the second parameter, or not at the level, at the same relative point of the second parameter. Let me give you an example. Where is that? Let's take this function, and let me go for the member here. Okay, and the second parameter also, let's say if you go for cousin. Okay, let me quickly show you the cousin function so that you can understand what the cousin function is. I mean, what's the syntax for it is. And if you go to the cousin function here, it accepts two members. It won't accept any level, and it won't accept anything, any hierarchy or anything like that, any number like that. It accepts two members. One is a member, and any member above it, ancestor member, means it should give you, let's say for example, if I select a day here, it should be any level above day, any level member above day. Either it can be month, or it can be year, or it can be something else. So for example, you know, this is 2013 April 23rd data. Let's say if I select 2016 as my second parameter, remember it should be ancestor member, which means any member above the level of whatever you have in the first member. So what it's gonna return, the cousin. The cousin is very tricky function. So this is gonna return 2016 for 23, which means it is giving you the same member of a different year. So this is good, right? So I have given 2013. I have a data for 2013 April 23rd, and can you give me its cousin on 2016? Its cousin on 2016 is 23rd for April 2016. So the cousin, this is how it works. The cousin, it's a horizontal navigation. Now let me show you a different example. Instead of year 2016, this belongs to April, right? April 23rd. Let me give you, let's say 2013. Instead of April, I'm giving you May. Okay, I'm giving a month member as May. If I execute it, it's gonna give me the relative point. So how it calculates is, this is very, very interesting. Let's say you have three members. Under the three members, under the 3 members. Okay, this cousin works very fine only in date dimension because it will have the same structure and same kind of data in everywhere. If I give this guy, okay, and if I give this guy, so what is this guy's position in its parent? This guy's position is the first one. So this goes and gets the first position of this guy. If I give this guy, this is the second position in this parent. So it will go, and if I give this as the second parameter, then it gives you the second position of this. If I give different year, okay, and like this, and if I give this member, this will go to the parent and parent. Okay, what is this first? What is the position of this guy compared to this guy? This is the first child's first child, and I have given this as the second parameter. So this gets first child, first child. So this value will be written. So this is how the cousin works. The cousin always goes to the parent member or the ancestor member that you have given of the current level. So let's say I've given ancestor member as this guy. So it's the same level, it goes to the parent. And here the same flow it follows, child.child, and it gives this value. This is the beauty of it. And the more beautiful thing is, I don't have semesters here. Let's say if I give a month, for example, April, okay? April belongs to the second quarter, first month, right? Second quarter, first month is April. And if I give semester 2 as my second parameter, then it will try to get the second quarter of it and first month of it. What is the second quarter of and first month of the second semester? It will be on the second semester, it will be July, August, September, and October will be the output. So it goes to its parent. You have to give 2 parameters. Remember, try to understand that. First parameter will be lower level and second parameter will be higher level. Let's say you have given this and you have given this. Then what is this level compared to its parent? And these guys, the same level value will be given. And if I given this and if I given this as the second one, then what is this position, relative position compared to its parent of the second parameter level that I've given, and the same relative point it will go and it will get the data of the value. So that is how the cousin works. It's a little tricky, but it's a beautiful option to use. Okay, so let's quickly see a couple of other functions. We will see range function. Range function is a pretty interesting one. So it gives you a range of values. For example, if I have this member, it's not ranger, it's range. So for example, if I have this and I have first member, I don't need to have anything like this. I mean the cousin or anything like that. This is a different way of representing. So it will be represented by using a colon. In the second part of it, you need to specify to where you want to get the data. So the first parameter takes what is the starting point and the second parameter takes what is the ending point. So for example, I know the dates and I've given 2016. So starting from 2016 and end to 2016, give me all the data. If I execute it, it starts from 13 April 23rd, and it goes until the second point meets. So if you go to the 2016 April 23rd will be the last one. All right. So this is how you can use the range functions. There are other functions which will give you, let's say this gives you from starting point to the end point, some set of values, right? So if you don't know what is the starting point, but you know only the end point, you can use this range function by using the null. For example, if you specify null, it starts from the first member of the level. What is the level? The level is date. First member of it, and it goes until this level. So this is the range with when there is no starting point given by using blank. So starting from 2013 Jan 1st, it goes up to the 23rd April 2016. Similarly, you can give let's say if you don't know the end point and you want to start the data from April 2016, 23rd of April 2016, you can give null. So if I execute it, it's going to start from 23rd April 2016 and will go in until the last member of it. If you don't know what is the last data that you have in your system, you can use this too. Okay. Now what will happen if I give null dot null is to null? A tricky question, right? Is it going to start from the start and end at the end? No, this is going to laugh at us. So I'm not specifying anything. Null comma null. If I give null comma null, what hierarchy it has to look at, what level it has to go for. There is nothing mentioned. So to get this, why you need a range operator? You can simply use this attribute level, right? If you use this level, anyhow, it's going to give everything that is starting from, from the start to the end. So that is why null colon null will not make any sense in the range. So there are few similar functions. Instead of going for starting to this point to that point, you can get, for example, if you want to get last 12 months data or last 15 months data or last 30 months data, you have a beautiful function called lead and lag functions, which you can use to get the previous year's data. Previous n number or next n number of data. So let's quickly see lead and lag, and we will end the session here after discussing the lead and lag. This is pretty straightforward one. If you have a member, this takes an input as member as an input, and let's talk about the lead first. So from this, how many members you want to go ahead? Let's say I've given 12. So starting from this member, this goes to the 12th member of it. So whatever the member that you have specified, from there it will go to 12 members. It adds 12 members. So it will be 5th of May. This is called positive lead. Okay. Similarly, if you give minus 12, it is called negative lead. So which means it will go back by 12 members. So positive lead means going forward. Negative lead means going back. Now, the same queries I copied, instead of lead, if I give lag, lag means, per English, it's go back. It go back by 12 members. Like it went to 11th of April. And if I give minus 12, it will go forward. Negative lag is forward, which is 5th of May. So now if you observe something, positive lead is nothing but negative lag, and positive lag is nothing but negative lead, right? So the first query, the first lead of 12 is equal to lag of minus 12, and lead of minus 12 is equal to lag of 12. How can you use this to get the most commonly requested report, last 12 months data? So let me quickly show you how to get the last 12 months of data. So for that, let me get the month at first place. Let's say, for example, I'm in Jan 2014. This gives me 2014 of Jan 2014 data. Now, how can I go back by 12 months? Dot lag of 12 or lead of minus 12 will give me the 12th month, right? Now, can I use this as well as the first query to get the range? We discussed about range, right? Range requires two inputs. One is the starting point and another one is the ending point. This is my starting point. Starting from this starting point, go to the current member, whatever you have given, whatever you have dragged. So what it's going to do is it's going to give you last 12 months data, ending at the current point, right? So this is how you can use lag or lead along with range to get the last 12 months data. Or if you want to get, very rare cases, people will ask for next 12 months data. So in that case, this will be the starting point and this will be lead of 12, which will take you 12 months ahead. If you don't have data at that month, then it will not return anything. For example, if it is 2016 of 9th month, and starting from there 12 months, I don't think it has 12 months data. It has only 2 months after that. Oops, what I've given. Lead of 12, 2016 9. Oops, the second one I have not changed. 2016.9. Okay. That's why it was causing some trouble. So if I execute it, it's going to give you only 2 months data because I'm starting at 2016 of September of 2016 and asking for the next 12 months data, but our system does not have 12 months after that. It has only 2 months after that, and it's returning. So the range and the lag and lead will do some magics like this. You can get last 12 months data or last 3 quarters data, last 4 quarters data. You can play with these functions. It's a beautiful one to use. So this is about a few key functions, and we will continue our discussions on many useful functions like this, which you will be using in your regular SSAS calculations. And we'll meet tomorrow again, same time. Thank you guys for joining, and have a great day.